Raghad, Muaiyad, and this is my friend Mawiah, Haitham. So we're year 1 medical students, and we're here to help you not only pass organic chemistry, but get an A, inshallah. Okay, so what we're going to do today,
Okay, we will have a small intro, then we'll start with chapter 1 revision. It's a little bit longer than chapter 2 revision. Then we will have some questions, and we want to hear from you some recommendations and feedback. Okay, now for the first lesson. How electrons are arranged in atoms. Most of you took this in the school. The atom, composed of what exactly?
Protons and electrons.
Wait, okay. Repeat.
Protons.
Yeah, the protons, where are they exactly?
Inside the nucleus.
Inside the nucleus, and also the neutrons, atoms, and the electrons around the atoms. Okay. Okay. Now, most of the mass of the atom is due to the nucleus. Why? Because of the protons and the neutrons. Their mass is higher than the electrons. And most of the volume is because of electrons, because they are running around the nucleus. Okay. Okay. Now, what are isotopes exactly?
Isotopes?
Yeah, isotopes.
Same elements with
Different?
Neutrons.
A different number of neutrons. So they have the same
Number of protons.
Okay. So they are atoms that are having the same chemical properties. Why? Because they have the same number of protons, same number of electrons, but the only difference is number of neutrons. So this is the reason. You have, for example, the boron. We have boron 10 and boron 11. Boron 11 is different from boron 10 with one extra neutron. Okay? These are, you can say, just basics, you all know them. Okay? Now, in the periodic table, you have the elements. Each element, you will have the symbol of the element, and you will have the atomic number and the mass number. What is the atomic number?
Protons.
Number of protons, which is also? Exactly. What is the mass number?
Protons and electrons.
Protons plus neutrons. Can we say electrons plus neutrons? Why?
Yes, electrons are different.
No, it's no. Why? Exactly. The electron's weight is way lower than the proton's weight. Okay, now you have here in the periodic table, actually we didn't get any questions about it, but you have here the metals, and here the metals, here the non-metals, and here the here unknown, exactly, metalloids. But we didn't have any questions about it. The most important part is the one before. Okay.
Yes, they will. If there's a need of a periodic table, the doctor will provide the quiz.
Now we will talk about how electrons are arranged in the atoms. This is very important. Try to understand it لأنه usually each quiz, or not each quiz, quiz 1 or like in the midterm you will have a question about it. And this is, you can see 3 questions, easy questions. Okay. First of all, let's start. You can see at the صح؟ قاعدين نشوفه؟ Okay. Okay, first we have the shells. The shells are like shell 1, shell 2, shell 3, okay? Then we have something called sub-shells, or the doctor, I think you call them sub-levels. اللي هن S, P, and D, okay? And we have also F, but you won't take F. We will focus on S, P, D. Now, these are the sub-shells. I mean, the shell, like for example, shell number 1, you will have S. Shell number 2, you will have SP. Shell number 3, you will have SPD. Exactly. طيب. These subshells contain orbitals. What are these orbitals? These are where the electrons are found. Each orbital can contain how many electrons? 2 electrons. These are the orbitals. For the subshell S, how many orbitals do we have? 1 orbital. 2 electrons, 1 orbital. Okay? Like this. And the electrons will be 1 up, 1 down when we write the symbols. Okay? Now for the P subshell, how many orbitals? 3. 3 orbitals, how many electrons? 6 electrons, exactly. For the 5. Okay. 1, 2, 3, 4, 8. 1, 2, 3, 4, 5. Yeah. How many electrons? 10. Okay. Now the electrons, when like you get a question about it, I don't think you will get about the orbitals, but you will get about the subshells for sure. The electrons will half fill before completely filling the orbitals. What does this mean? Yani, let's say you have now 8 electrons. You will start from here. Let's say, okay, that's 1, 2, 3, 4, 5. Okay, let's say you have 10 electrons. Okay, you will start. 9 electrons. Okay, you will start filling like this, up, 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 then go down. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, yani I mean half. First of all, you will fill half of them, then you will complete them. Okay, until now. Any question about these? You got the subshells, the shells, the orbitals. Okay. Okay. Now, what are the valence electrons? The outermost electrons, exactly. The outermost electrons in the valence shell, okay? The outermost shell. Now we have something called in the book kernel. Kernel is the atom with the inner electrons. Like, what does this mean exactly? You have here the atom, okay? And you have here electrons in the orbitals. So the electron with all the inner the nucleus with all inner electrons is the kernel, okay? And the outermost are the valence, okay? Right. طبعا we have exception, which is the helium. Exception from the octet rule. We will talk about it later, inshallah. The group numbers correspond the number of valence electrons. Like, as I showed you the periodic table before. Group number 1, how many valence electrons? Group 2? Group 17?
7.
Group 18?
8.
16?
6.
Okay. Because we need this and we will talk inshallah بعدين about the bondings. Okay? As you can see also in this picture, the kernel is the nucleus with all the inner electrons except the outer one, the inner valence. Okay? Okay. Now the octet rule. The octet rule is that the atoms tend to gain or lose or even share until they reach the 8. Exactly. Okay? Yeah. In the 4 orbitals. Why 4 orbitals? 2 each. Okay. Yeah. Now we'll start with the bonding. And we talked about the octet rule that will lead to the bonding.
Okay, so before starting with the ionic bonding, so do you know what are inert gases or noble gases? Yes, they have the stable electron arrangement in which they have a full octet rule, okay? And they do not combine with any other elements because خلاص they are stable. Next. So starting with ionic bonding, of course most of you know, but just to revise with you. So they are formed by transfer of one or more valence electrons, right? From one atom, which is, yes, to the other, which is, okay, so, and they form ionic crystals. Ionic bonds form ionic crystals. So this is an example. We have Na, which is a metal, chlorine, which is non-metal. Tamam. So Na donates its electron to Cl. Okay. Here, so here so this is just a difference between the Na or Cl and or between metals and non-metals. So atoms that loses its electrons are most likely to be metals. And they become cations or anions.
Cations.
And what are cations?
Positively charged atoms.
Okay. And they are mostly electropositive. Do you know what electropositive mean? Yeah.
They lose electrons.
Yes, the tendency to lose an electron. And atoms that gain electrons are most likely,
Anions.
yeah, and they become anions, and they are most likely to be electronegative, or they are electronegative. So this is the trend between of the periodic table that has electronegativity and electropositivity. And as you can see, that the trends of electropositivity and electronegativity are opposite, and I think you should know them. Why did I cross the inert gases?
Because they're stable.
Yes, because they are stable. So as you can see, as we move up and right, we have increase in,
Electronegativity.
and if we move from to left and down.
Electropositivity.
So what is the most electronegative atom?
Fluorine.
And what is the most electropositive atom? Yeah, it's called francium. So these are simple terms, but they are related to each other. First of all, we have ionization energy. Do you know what is ionization energy?
How much it's.
Yeah, it is the tendency of a neutral atom to resist the loss of electrons. So, for example, sodium, does it want to gain or lose electrons? Lose electrons. So, and the ionization energy is to resist the loss of electrons. So, do you think sodium has high or low ionization energy?
Low.
Low, because it wants to lose electrons. It doesn't want to resist losing electrons. Okay? And then we have electron affinity, in which there is an energy change when a neutral atom attracts an electron to become a negative ion. So when an atom gains an electron, there is an energy liberated, and this is called electron affinity. Okay, so and what's the difference between electron affinity and electronegativity? Do you know?
Electronegativity attracts electrons. It's like how much it can attract electrons.
Yes.
Affinity is change, but electronegativity. You're talking about electronegativity and affinity.
Yeah.
Negativity is a measurement.
Okay, so electronegativity. So we said that electron affinity is when the energy liberates when we gain an electron, but in electronegativity is the tendency of an atom to attract a bonding pair of electrons. So it wants to steal electrons from already formed molecule. That's the difference. Okay? Any questions?
Guys, you can interrupt us. يعني, when you want, عادي, just ask, okay?
Mhm. So these are the trends that summarizes all of the trends in this chapter, and this one you need to memorize, okay? Not the periodic table, but the trends. Okay, as you can see, all electronegativity, electron affinity, and ionization energy are both, they are all increasing when you move up and right. But the only case we have that increases in left and down is what?
Electropositivity.
Yes.
Okay. Now to the covalent bonds. The covalent bonds يعني, will make most of your organic chemistry. يعني, we are talking about organic chemistry. So what? Carbons. Carbons make what? Covalent bonds. Exactly. Okay, now the elements that have similar electronegativities, or you can say they are like يعني, the electronegativities for both of them are the same. So they tend to bonds by sharing electron. Okay, what is the covalent bond? It's a covalent bond that forms between two atoms, share one or more electron pairs. And what is the molecule? What is the molecule?
What?
Molecule.
What is a molecule?
Yeah.
Two or more atoms.
Yeah. Two or more atoms are attached to each other by which bond? Covalent bond. Okay. Right. Yeah. I need to mention here something. If they have equal electronegativities, like let's say chlor with a chlor, you know all the gases like Cl2, F2, I2. Cl have how many what do you call it? Valence electrons? 7. Okay. يعني it needs one bond. And the another Cl? One bond. Okay. So now one bond, one electron will be shared with the another electron from both fluors, and it will be shared equally. Why?
They have equal electron. There's no difference in electron.
To be stable for both of them.
Yeah, your answers are right, but you can say because the protons in the nucleus are equals. So the protons in the first chlor will like attract the electrons from the another chlor at the same power. Wait. Okay. Yeah, exactly. Okay. Wait.
This will always form non-polar.
This is for non-polar. No, it is non-metal with non-metal. You asked.
Do we have to memorize like the exceptions of the octet rule?
Exceptions of what?
The octet rule. It's just helium.
I think just know it's
Helium.
It's just hydrogen and helium. Hydrogen, how many electrons does it need to? Yeah, just 2, not 8. And helium, it's already stable.
يعني just know إنه they are you can say عادي بتعرفين لحالك بس شو بسموها؟
I think we should kick your one out.
Sorry. But the bond energy is the energy necessary to break a molecule of covalent bonds. Now, if we have a molecule, 2 atoms attached with each other by a covalent bond, the energy that we need to break this bond is the bond energy. Okay. Okay. Now, I need to mention something here that, like, not think only about the covalent bonds is like the attraction from the protons of the first atom, it attracts the electrons of the second atom and vice versa. But I need to say something. We have other forces like the repulsion between the nuclei itself. Between 2 nuclei we have repulsion. Also, between 2 electrons we have repulsion. This will lead to what? This will lead to having a bond length. Okay? And the bond length for the ionic, it is actually longer than the covalent, and for the triple bond, it is shorter than the single bond. Why?
Because the bond is stronger.
Stronger, yeah. لأنه في more sharing of electrons in the triple bond, that's why it will be stronger. It will be there will be more forces of attraction and also repulsion, and it will lead to shorter bond, than the single bond. Okay, now we will start with the carbon. Our main topic. Carbon and covalent bond. Carbon, how many covalent bonds can make? 4. Why? 4 valence electrons, so it can make 4. حتى it reach to stable. Okay. And for sure, carbon is neither electron positive nor strongly electron negative. Okay. What is a radical?
It's like not included. It's alone, right?
Yeah. So radical is actually a molecular fragment with an odd number of unshared electrons. Unshared electrons. Like for example, oxygen. You will take بعدين an oxygen radical of the oxygens in the body will be toxic. Why? It can attach with water and cause H2O2, which is toxic to the body. So radicals just know that they have odd numbers of unshared electrons. Okay. Like let me give you an example. Exactly like the yeah. Mm-hmm. Yeah.
CH3?
No, not the CH3. He said, I think you said F, right? F. CH3 no. I mean the radical. يعني مثلا عندك انت الاكسجين اوكي في كم بوند covalent bond 6 covalent 6 اوكي فعنده كم unshared bonds 2 فهاد even number not odd number. The odd number I think like the sodium how many covalent bond 1. Yeah, that's why if it's free in the body it will be toxic then radical. Okay, now the carbon, as we said, it can make 4 covalent bonds. So this is catenation. It is the ability of the atom to make a chain like this. What is this?
CH3.
CH. Yeah, it's no. I mean, what do we call it?
Okay, so starting with the polarity, non-polar and polar bonds, this is very, very important. Many questions on the exam. Okay, so we have to know the difference in electronegativities and what do they make. So first of all, let's know what is a non-polar covalent bond. So in a non-polar covalent bond, the electronegativity difference is very, very small, very tiny. So it will be less than 0.5. And the polar covalent bonds, the electronegativity there will be like an electronegativity, but it will not reach a very high electronegativity to reach like an ionic bond. So a covalent bond in which electron pair is not shared equally. So why the electron pair is not shared equally?
Difference of electronegativity.
Yes, exactly, because there's a difference in electronegativities. So the more electronegative atom, the one that attracts electrons,
It's
will
like
be,
electronegative.
yeah, it will be like partially negative because it will attract the electron more to itself. And the less electronegative atom will carry partial positive charge. So as you can see here, we can describe the partial negativity and positivity in 3 different ways. As you can see here, this delta positive means partial positive. Delta negative is partial negative. And as you know from this diagram, chlorine electronegativity is much higher than hydrogen, so it's 3.2 and 2.2. So this one will be the more electronegative atom and will carry a partial negative charge. In this shape, you can see that the partial positive charge will carry like a plus sign, and then we draw an arrow from the partial positive to the partial negative. You understand? Yes? Okay, so what is the type of bond between F and H?
Polar covalent.
Yes, exactly. So F we have the electronegativity is 4. H is 2.2. So what do we do?
We subtract.
Yes, subtract 4 minus 2.2, which gives 1.8. And as you can see, 1.8 is
Non-polar.
it's a polar covalent
Okay.
because it's between 0.5 and 1.9.
Okay, got it.
Okay.
Do we need to memorize?
Yeah, you need to memorize these values.
Like we have values before.
Yeah, no, yeah, they will be given. But this,
No need. هدول will be given already, but you need to know. حتى you say if it's polar, non polar.
okay. So we also have the double bond and the triple bond. Double bond is when we have how many electron pairs are shared between 2 atoms?
2.
2. And how many electron pairs are shared in triple bond? 3. Yes, exactly. So we have carbon dioxide. Yes. We will have carbon, and then it forms 2 double bonds with 2 atoms. This is carbon dioxide. Okay. We have HCN. The C will form a triple bond between C and N, and then we have also C2H2. So these are the examples given here. So this is a double bond, this is a triple bond, this is a triple bond.
Okay. I know يعني it's this a little bit boring لأنه just info يعني there's no solving of like this بس إن شاء الله يعني حنيجي على الفالنس charge sorry الفورمال charge and الفالنس electron بالريبيس bonds هون يعني try to focus. Okay. I have a question about the second lesson. What is the difference between valence and valence electrons? It is different. Go ahead.
So the valence is like opposite to the kernel. So the kernel is in the inner, the nucleus and the inner shells, and the valence is the outer shell. The valence electrons are the electrons in the valence shell.
I got what you mean, but let's see like this. Wait. Yeah.
Valence electrons are electrons in the outer shell. Valence is the needed electrons to be stable.
Exactly. Right. Repeat it بس لو تعلي صوتك شوي.
Valence electrons are electrons in the outer shell.
Mhm.
Like oxygen has 6 valence electrons.
Mhm.
But the valence for oxygen is 2
Exactly. So you should know this, that the valence different from valence electrons. Valence electrons, as we said, we can know it from the periodic table. Like the oxygen in group 16 have 6 valence electrons. But the valence is the number of the bonds that an atom can do it, اللي هي نفسها number of electrons that the atom needed to be stable. يعني الأكسجين 2, الفلور 1, chlor 1, carbon 4, and hydrogen 1. يعني هي bonds that the atom can make it. Okay.
So now with isomerism, as you know, what is a molecular formula? Yeah.
CH2.
Yes, it shows the atoms and the number of atoms. What is a structural formula? Yes, exactly. It shows the arrangement of atoms. So, what is a structural constitutional isomer? It is in which we have the same molecular formula but different structural formula. So, structural isomers will have different chemical and physical properties because we have different connectivities between the atoms. So, this is an example of a molecular formula, and this is the structural formula. As you can see, it shows the number of atoms and the type of atoms. Here it shows the arrangement also. And this is an example of a structural isomer. As you can see, they have the same molecular formula. If you count the number of atoms, they will be the same, but they have different arrangements. Yes.
How to know which one is iso? Yeah, this one is clear, but many times I can't recognize which one is iso and which one is the
And butane.
Yeah.
So what is natural butane? Natural butane is when we have the original butane. So we have 1, 2, 3, 4. This is natural butane. So the chain is the longest, and it is the original one. In the isobutane, as you can see, this is not a butane anymore. As you can count it, 1, 2, 3. This is what? Propane. And since we have a methyl group, it will become methyl propane. So methyl propane is also known as an isobutane. So, for how many structural isomers can be obtained with the molecular formula C5H12? The one way you can do it is by writing all the isomers. As you can see here, we have 1, 2, 3, 4, 5. This is C5H12, an alkane. We can also do it by 1, 2, 3, 4.
Can we close the door?
Yes.
We have a lecture.
Yes, it's okay.
Sorry.
Okay, so we have 1, 2, 3, 4, and then we have a methyl group on the side. Or we can also have a propane, which is 1, 2, 3, and then we have 2 methyl groups. So as you can see, how many structural isomers can we form? 3. Okay, so for this lesson, abbreviated structural isomers, just know the condensed structural formula looks like this.
هلا هو ممكن يسألنا يعني كم ايزومر عنده احنا بنقعد نجرب.
They may ask you how many structural isomers are there, but now I will give you how you can calculate it in an easy way.
Okay, now the formal charge. We received the questions on the form about the formal charge. No, please solve questions about it. Now all lone pairs, what are the lone pairs?
The ones that are not electrons.
Yeah, the unshared electrons, exactly. They are belonging to the atom. Okay, and about this, yeah, no need. But here we should know that when we want to talk about the charge, we should know 2 things: the Lewis structure and the formal charge. Always draw, then found the charge. Right. Okay. Now the formal charge. Memorize this formula like your name. لأن إن شاء الله, and I think you will get a question about it. It is the number of the valence electrons in the neutral atom. Number of valence electrons اللي هنا من periodic table, okay? Minus unshared electrons minus half of the shared electrons, or you can say minus the dots, which are the unshared electrons, plus the bonds اللي هنا half of the shared electrons. Okay, now we'll take examples. هنحل قدامكم ونشوفوا طيب. هلا أول شيء NH4 positive. أول شيء بتحطوا النيتروجين عادي، أوكي؟ النيتروجين كم بوند بتقدر تعمل؟ 3 bonds صح؟ ف 1 2 3 this is H number 1 H number 2 H number 3 أوكي، هلا هون المفروض يكون في 2 electrons اللي هنا اللون pairs. We'll remove these lone pairs and put the other H. طيب, how can we calculate the formal charge for the nitrogen? أول شيء, what are the number of the valence electrons of this nitrogen when it has 0 charge, يعني it is neutral atom? 5 minus. What is the number of shared electrons, the dots?
4
0. When you draw the Lewis structure, look at it. أول شيء, without the Lewis structure, the nitrogen from the periodic table have 5 valence. You can't hear me? So for the record, nitrogen from the periodic table, it has 5 valence electrons. خلاص, this is 5. Now, what is the unshared electrons, the dots? There is no dots. Okay, there is no no unshared electrons. All the electrons are shared. Okay, so it will be 0 minus the shared electrons.
4
How 4? 8. How?
1 electron from the hydrogen and 1 from the nitrogen and 1.
Exactly. You can say 1, 2, 3, 4, 5, 6, 7, 8. So 8 multiplied by 2 can
16.
8 multiplied by 2. Oh, sorry, divided by 2. I'm saying multiply. I'm sorry. So it will be 4, so this will be 1. So the positive one is from the nitrogen. Still, okay. Now let's make it to the hydrogen. The hydrogens have 0 charges. Now let's see how the hydrogen has a 0 charge. Our sheet, what is the valence electrons? 1 minus the unshared electrons.
2 by 2.
0. The shared electrons. I'm talking about
2 divided by 2.
شوفوا الformal charge, let's look at the atom alone. Okay, the atom alone and what is
Attached to it.
exactly what is attached to it. Okay, that will be 2. It will be 0. The same for all hydrogen atoms. Now we will do it on NH2. Inshallah, you will get it.
It should be plus, صح?
Sorry. Dividing by 2 from the formula here, the number of the valence electron minus the unshared electrons. Sorry, here it should be plus. I will make it plus half of the shared electrons divided by 2. Okay, listen, you can take it as dots plus bonds. Okay, يعني شوفي عندك مثلا هون you have 5 valence electrons minus how many dots? 0. How many dash? No, 1, 2, 3, 4. So 4. Yeah, it's 8 electrons, exactly. So 4. Okay, 5 minus 4? Positive 1. Got it? Well, that's good.
I think people get intimidated when they see the
Yeah,
dividing side.
exactly. When we talk about the electrons, the shared electrons, it's different from the bonds. يعني one bond